Hey, what's going on YouTube? It's Elliot from the Techie, and I'm back at you with another video in our Proxmox to Kubernetes build. In the last video, we installed Longhorn, and that gave our Kubernetes, our cluster, replicated storage so that our data is written across multiple nodes and can survive a node going down. We also swapped out the default local path, which was storage class, and set Longhorn as the new default. And we proved that it all worked with a test PVC. So storage is good, it's handled, it's all set up. But there's still a problem that we need to fix in our setup, and that's secrets. So, say if we wanted to give a pod an API key right now, we would have to go and hard code that into a manifest or into an environment variable, and that's just not the way that you want things done in production. So today we're going to install a HashiCorp Vault, and we're going to deploy it on top of our Longhorn storage that we've already set up. And we're going to initialize it using Shamir's secret sharing, where the master key gets split into 5 different pieces. And we have to unseal that vault using those keys. Then after we do that, we'll store our first secret, and then we'll wire up some authentication so that our pods can pull the secrets automatically through a sidecar without having to hard code anything anywhere. So before we get into that, let me also just point out, if you remember from video 1 of the series, we did everything in our command line or our terminal and set up our Kubernetes cluster there. But I wanted to show you just the visual representation here in Proxmox, where we have our server and our 2 workers. The server, if you remember, we set it up with 4 CPUs, 8 gigs of RAM, and a 50 gig hard drive. And both workers got 8 CPUs, 32 gigs of RAM, and a 100 gig hard drive. So I just wanted you guys to see this. I also have a couple other VMs working or running that I will get into at a later date that are some other projects that I'm working on. But I just wanted you guys to see that visual representation of what we did before we get started. And then also at the end of this video, another thing that we're going to do, and I'll go ahead and bring it up here and have him ready, is we're going to use Claude Code to help write a test for us. So let me pull it up here just a minute. Yeah, we're going to have him do one of our tests at the end so that we can validate that our cluster is good and going. So let me pull them up here. All right, and let's get into it, guys. So like I said, the first thing that we're going to do is we're going to need to install the vault, and we do that with Helm. So let me come over here. Let's SSH into our Kubernetes server. So I'll say SSH. My username's Elliot at 192.168.68.101. Okay, so we are into our server. Now, the first thing we need to do is get the vault from our repo. So we'll say Helm repo add HashiCorp. It's at https://helm.releases.hashicorp.com. All right, and as you guys know, I normally do these before, so it's already downloaded. So let's go ahead and update it. Helm repo update. Okay, we're good there. And now let's actually go ahead and install the vault, giving it we're going to tell it to store its data on our new Longhorn storage. We're going to enable the agent injector so that it can push secrets into the pods as sidecars. And we're going to go ahead and run this thing in production mode and not dev mode so you guys can see how it really works in the real world. So I'll say Helm install vault HashiCorp/vault. Okay. And then we'll say -- namespace is vault. We'll say -- create -namespace. I'm going to say -- set server dot data storage and storage. Yeah, so storage class is going to be Longhorn, where we set up our block storage, Longhorn. So I'm just checking my spelling, okay? And we'll say dash dash set server data storage dot size equals 5 gigs. And then we'll say dash dash set server dot dev dot enabled equals false. You don't want dev mode. And enter. Oops. Yeah, that was my fault. I didn't mean the dash. And I need to spell HashiCorp right. All right, there we go. Finally got the vault set up and it is deployed. So good. Now let's go ahead and let's clear our screen here. We can check on our vaults. So what we can do is we'll say kubectl -n vault get pods -w. All right, so we see vault 0 here. That's our vault that we created. 0 is showing that it's not ready. That's fine. That's by design. Since we are basically running the vault, well, okay, since we're doing this ourselves, we have to initialize the vault. You know, it can't serve traffic until we initialize it and unseal it. So that's by design. So that's basically the next step that we're going to do here. Is we're going to come and initialize the vault, and what that's going to do is create the encryption keys that's going to protect everything in the vault. Like I said earlier, we're using something called Shamir's secret sharing, and it's going to give us 5 master keys that are well, you get 1 master key that's split into 5 shares, and you need 3 of those 5 shares in order to be able to unlock your vault. So that's what we're going to set up here, and we do that by saying kubectl -n. We'll say vault exec vault -0 - vault operator init. All right, and we'll say key dash shares equals 5, and we'll say key dash threshold equals 3. So like I said, we need 5. We're going to get 5 keys, and we're going to need 3 of them to unlock. Now, you see them here. These are your unseal keys, and you get your initial root token. I'm not going to, normally you don't want anybody to see these because these are the keys you need to unlock the vault, and I'm going to undo this after we're done, so you're not going to be able to access this. But in the real world, this would be the point where you store these somewhere, because you will need these if you ever have to unlock the vault manually again. And if you don't, you will lose all your data, and you will have to do this process over again to set up a new vault. So make sure you have these keys secured, and that's basically all I'll say. So now let's go ahead and unseal it, and we'll unseal the vault by saying kubectl -n vault exec vault -0. Now remember this command too, you're going to be using it a lot going forward with this process. So just make sure you remember that kubectl -n vault exec vault 0 -- okay? You'll need that. And then next we'll say vault operator unseal, and then we need one of these keys. All right, good. And so as you see here, the seal type is Shamir. The vault is initialized. The vault is still sealed, showing true. We have 5 total shares. We need 3, and the unsealed progress is 1 of 3. So we're making good progress. So let's do it again. Got to do it 2 more times. So we'll say kubectl minus n vault exec vault dash 0 dash dash slash, and we'll say vault operator unseal and we'll take our next key. Good. All right, and do it again. kubectl minus n vault exec vault dash 0 dash dash slash. We'll say vault operator unseal. Take our next key here. All right, and as you see, the status of the vault has changed to false now, so it is no longer sealed. Great, we're good. Now, the next thing that we need to do is enable the secrets engine, and it's the KV secrets engine. And what this is Vault, it uses a pluggable secrets engine. In this instance, we're using KV version 2, and that gives us versioned key value storage, which basically means that we can store secrets and the vault will keep a history of the changes. And that's particularly useful if you need to do any kind of audits or rollback or anything like that. So the first thing that we need to do this to enable the engine is log in with our root token that we got up there. So we're going to say kubectl minus n vault exec vault dash 0 dash dash slash. And let me come here. Had a typo. kubectl minus n vault exec. Okay. And now we'll say vault login. And we'll put our root token up here. Let me change this. All right, success. We are now authenticated. The token is good to go. All right. So now let's go ahead and enable the KV-v2 engine. And we do that by saying kubectl minus n vault exec vault dash 0 dash dash slash, and we say vault secrets enable dash path equals secret kv dash v2. All right, success. The engine is now active at the secrets thing. Or that path, sorry. Now, let me go ahead and clear my screen. Now let's go ahead and store our first secret. And in this case, I'm gonna just demo us putting in an Anthropic API key. It's not my real API key, so don't worry about any security or anything like that. But what the point is, what you have to realize is that from this point on in our environment, keys live in Vault encrypted storage. So they don't live in any environment variables. They won't live in any pod specs or even in Git. We're basically showing you how this whole process works. So again, I'm just using a demo key, but in your setup, obviously replace it with your real key in your build if you want to see how this works. So we'll say kubectl minus n vault exec vault dash 0 and this time dash dash. Now it's a new command, so we'll say vault kv put / or backward slash, whatever. We'll say secret / agent. This is where we're going to put it / config. Okay, and then we'll call it Anthropic. Excuse me. Phone call there. So we'll say Anthropic dash API dash key equals, then let me start with like SKANT something 1 2 3 4 5 6 7 8 9 0. Okay, that's good enough, and the key is stored. All right, so that's all you need to basically put the key in there. Now, if we want to see this key, what we can do is we can say kubectl -n vault exec vault -0 // and we'll say vault kv get, where do we put it, secret /agent /config, and type the kubectl command in correctly. Okay, and there we see our vault that we, or our secret that we entered into our vault, right? All right, good to go there. Now, let's go ahead and configure Kubernetes authentication. And this will allow the pods to authenticate to our vault using their Kubernetes service account tokens. So again, no hard-coded secrets anywhere are going to be needed. They're going to be using these service accounts. And let's go ahead and enable the authentication method. And we say kubectl -n vault exec vault -0 // and we'll say vault auth enable Kubernetes. All right, so we've successfully enabled Kubernetes auth in the Kubernetes directory. Good. Now we need to go ahead and configure it so that it can talk to the Kubernetes API. So we say kubectl -n vault exec vault -0 and the new command --sh -c single quote. We'll say vault write to auth /kubernetes /config. Okay, and then we'll say Kubernetes _host equals quote https $capital Kubernetes _port _443 _TCP _ADDR :443 close quote enter single quote. Okay, so we've now written that data to our auth /kubernetes /config file. It's good to go. Now we need to create a vault policy for the agent. Now, policies control who can read what inside the vault, and the one that we're going to create says anything under the agent path is read only. So the agent can fetch its API keys, but it can't modify or delete them. That's kind of what the security measure that we want to set in place here. So we're going to say kubectl -n vault exec vault -0 -sh -c single quote, and we'll say vault policy write agent policy dash then SN EOF. All right, and we'll say the path is secret data /agent / we'll do a wildcard star, and then we'll do a directory to a curly brace. So the capabilities are going to be read. All right, capabilities equals read. Okay, we'll close that and single quote. All right, good deal. Our policy is set up, and again, this basically just grants read-only access to the secrets under the secret /agent directory, that path, and the agent pod can read its API key, but it can't modify it, all right, or delete it. Now we need to create the agent namespace and the service account. So we're going to create a dedicated namespace for the agent stack and a service account that the vault will be able to recognize. So just think of this as like the identity card that for the agent that vault checks before handing out any type of secrets, okay? And let's go ahead and create the namespace. We'll say kubectl create namespace agent. All right, so we created that there. And now we just create a service account for the agent. So we'll say kubectl -n agent create service account agent-sa. So service account agent-sa has been created. Great. And now this is the last thing that we need to do is we need to bind the Vault role to that service account that we created. And this is kind of like the glue between Kubernetes and the Vault and the HashiCorp Vault, where we're telling the Vault when a pod shows up with that agent SA service account from the agent namespace, go ahead and trust it and give it the read-only agent policy that we created, or that we're going to create here. So let's do that here. We'll say kubectl -n vault exec vault -0. There we go. // Make sure my spelling's right, good. And we'll say vault write, and we'll go to auth/Kubernetes /role /agent /role agent-role. All right, and then we're going to bind the service. So we'll say bound _service _account _names. Okay, so we said it's going to be for agent-sa. Okay, so for this name, and we're going to bind it to that name. All right, to that name, and we're also going to bind it. So we'll say bound _service _account _namespaces. Yeah, namespaces equals agent. Okay, and the policies. So we'll say policies equals agent-policy. Okay, and we'll give it a TTL. We'll say TTL of 1 hour, and that's how long the it'll be before it has to re-authenticate again. All right, now you're going to see this warning sign, and it's safe to ignore this. The role is created and successful, and we're good to go. Now, let's verify that the role, let's verify it. So let's say kubectl -n vault exec vault -0 // okay, we'll say vault read auth/Kubernetes /role /agent-role. All right, so now this reads back the role configuration and basically confirms that we are bound. Here's our name, the agent that was bound, the namespaces, the policy that we bound to it, the token policies. We have our TTLs of 1 hour. And this is basically our connection showing that everything worked. Now, what I can do here is I can, like I said, since we're going to use Claude to verify all of this for us, all I'm going to do is I'm going to ask Claude to, I have a test that I already created, and I'm going to ask it to use the test that I set up and then to print out my test key just to make sure that this all works, okay? So I'm going to talk to Claude and let's see if we can get this to work. Can you use the test I'm about to upload to verify my HashiCorp Vault implementation and show me my Anthropic API key? All right, and what I just pasted there, as you see right here, here's the test I ran, and let's see what Claude comes back with. and it was cleaning up an old test that it had there, so don't worry about that. Like I said, I always test these before I show them to you guys, so Claude was just doing some maintenance work there. But as you see, he's SSHing into my device here at 101. It sees the test. It tells us pod is running to a 2, sidecar injected successfully. Now it's going to read the secret that I put there. There we go. So as you can see, our Vault Agent Injector is working perfectly. Here's your secret. Of course, you would not do this with production. I'm just showing you that this is the process and how we can get it and how Claude is able to also see it if we give it access. So our setup is good. Our setup is solid. I am so glad that you guys are able to see this process, and I hope you were able to learn something. If you want to follow along for the rest of the series, you can go to my website at www.thetechie.com. From there, you can also have access to my GitHub repo. It's under the resources page. You can also follow me on LinkedIn, and I do a lot of posts and things of that nature as far as network automation and AI learning. Again, this whole process is to eventually have an AI agent run my infrastructure autonomously. That's what we're testing and building towards. So we've got a lot more good videos coming ahead in the future, guys. So I hope you were able to find something valuable from this, and I hope to see you again in our next video. Talk to you soon.